Okay, sometimes more than two quantities are changing within a certain relationship. At this point, you must consider the product rule, the quotient rule, and the chain rule when differentiating, expressing, blah, 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 blah. So what's the derivative of length times width? Times. You just forgot the product rule. Derivative of the first times the second plus times the first. Oops. Okay, what about the area of a triangle? Okay, what about a cylinder if I allow the sides of the cylinder to change? People comfortable with what the half is and what the pi is out in front? They're just constants. Put them out front, cover them up, and then do the product rule. Right? The cone. I love my computer. Okay, part. Find the equation that relates if h is a constant. Good. Good. I never thought about it that way. Use the formula above and make dh over dt 0. Because it says h is a constant. It's not changing. So, what? That's cool. So, have to be able to manipulate formulas and see which is constant and which ones aren't, and blah, 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 blah. Okay. Page 2. Sphere we did this morning, dv dt equals 4/3 pi times 3r squared dr over dt. Rectangular box. Here's where you hate me. Product rule times 3. Derivative of the first times the second and third plus the derivative of the second times the first and the third plus you go. Okay, the one that I like. The derivative form of Pythagoras. What's the derivative of x squared? Close. But everything's, time is the variable. Time is the independent variable now. So it's always over dt here. Plus 2y dy over dt equals 2z dz over dt. Can anybody clean that up, make it even prettier? Divide everything by 2. So x dx dt plus y dy dt equals z dz dt. This is the derivative form of Pythagoras. Just like I wasn't subtle enough. There. Subtle? No. I like the derivative form of Pythagoras. I am a big fan of the derivative form of Pythagoras. Now, if you scrunch your nose up in me and we go, Mr. App, that's hard, okay, we'll do the derivative form of the cosine law instead. No. I should, but no. Okay, find the equation that find the equation that relates dx dt and dy dz dt if y is a constant. Okay, take that gray formula and see how it changes. If I say y is a constant, there's no dy over dt, it's 0. So it's x dx dt equals z dz dt. If y is a constant, then as soon as you read that, you know dy dt is 0. Diagonal of a rectangle. Find an equation that relates dd dt, dx dt, and dy dt. Blah, 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 blah. Okay. We'll zoom in here. Square root is what power? Yay! You guys are doing square root. 1 power. So dd dt equals 1 over 2 x squared plus y squared to the negative 1 over 2 times good. And you're finished. Well, I guess you're not yet. Well, it actually cleans up pretty nice in a mathy sort of way. just take a 2 out in front. So it's x dx dt plus y dy dt over the square root of x squared plus y squared. No. It's just Pythagoras written in a different way, all you folks. You should see this formula here and the one up above. X dx dt plus y dy dt equals z dz dt is exactly the same formula. Because you could have d squared equals, and you do the same question. Is dz dt from above. It's the same thing. The diagonal of a rectangle is just the hypotenuse of a triangle. Right? No? Tan theta equals y over x. What's the derivative? I know there was 100 there. I changed it to x. That ain't subtle either, is it? Whoosh rule! Derivative of tan. Secant squared theta d theta dt equals dy over dt x minus dx over dt y all over x squared. Okay, solve that for d theta dt. Take the secant squared over to the other side of the equation. Now, what may blow your mind away is I don't like secant. Everybody know where the secant squared button is on their calculator? Yeah, neither do I. Yeah. That's annoying. What? Yeah. So I tend to not use secant squared. I'll write it as cos squared. Okay. So I will ask you to do derivatives with angles. Aww. Aww. Yeah. I tend to like to put speeding planes flying over ahead, right? And as soon as you watch a plane do this, as soon as you watch a plane, you're standing here and then a plane, you see a plane here. Yeah, I know I can't draw. It's a plane, look at it. So you're standing here and you're watching how fast that angle here is changing. It's how fast you have to move your head as the plane goes above you. So it's that motion. And then your head snaps off when you reach 90 degrees. But okay. Okay, so is this the first one? A taxi drives 3 kilometers east, then turns north, traveling at. Mr. Appen, does this sound like a lot like physics? Yep, because it does. Oh, it's not hard. Is it your kryptonite? Is it green kryptonite or red kryptonite? That's the problem. See, green kryptonite won't kill you. It'll just make you really sick. It's red kryptonite. Okay. Okay. Well, we can draw a taxi going. So here's our taxi going 3 kilometers east. 3 kilometers. Then turns north. Traveling at 50 kilometers an hour. How fast is the distance increasing when the cab is driven 4 kilometers north and it's traveling at 50 kilometers per hour? Okay, so the first thing that I always ask children to do is to find the hypotenuse. Find the hypotenuse. Use Pythagoras, use your Pythagorean triples, use the force. Use your Jedi mind powers. 5. Z is 5. So we know X is 3, we know Y is 4, and we know Z is 5. We also know dy dt. What's dx dt? 0. Pourquoi? Because it ain't going any more easterly. It's only going northerly now. So dx dt is 0. Okay, so we're going only north. So we get out our derivative form of Pythagoras. X dx dt plus y dy dt equals z dz dt. Put all the numbers where they need to go. 3 times 0 plus 4 times 50 equals 5 times we don't know. Four times 50 is 200. 200 divided by 5 is 40. 40 kilometers per hour. In a northeasterly direction, no, at an angle of 35 degrees south of east of south. Remember doing all that? We don't do that here. A bug is walking away from a wall 40 meters high at a rate of 3 meters per minute. At what rate is the distance from the top of the wall changing when it is 30 meters from the wall? Okay, so we've got the whole 40-meter wall, and we're 30 meters from the wall, 30 meters, and we're walking away at a rate of 3 meters per minute. And how fast is this distance changing? Quick, find the third side. 50 meters, okay. So we know x and we know dx dt. X is 30 and dx dt is 3. We know z is 50. We're asking you for dz dt. We don't know that. We know y is 40. What's dy dt? Why? Because the height of the wall isn't changing. The wall isn't falling down. There is no earthquake happening here. Okay? Use the derivative form of Pythagoras. Dx dt plus y dy dt equals z dz dt. So put in 30 and 3 and 40 and 0 and 50 and dz dt. (90 over 50). 9 over 5. Yeah. 9 over 5 meters per minute. So like 1.5 8. That bug is trucking. Okay. A right triangle has a constant length of 10 centimeters. One leg of the triangle increases at a rate of 2 centimeters per second. When it is 6 centimeters long, what is the rate of the other leg is decreasing? Really? 10, 6. Okay, use Pythagoras, find the third side. 8. It's just a 3, 4, 5 triangle, all prettied up like. The hypotenuse is a constant length, so dz dt is 0. One leg increases at a rate of 2 centimeters per second. So that's why. So dy dt is 2. This is, except for I always call these ones x's, so maybe I should be consistent. So we're asking you to find dy dt. The 18 might need related rates. No? Did you? Fun. You guys were, or they were? Because they were in Ashcroft or something. Yeah. Hmm. 6 times 2 plus 8 times dy dt equals 0. So you should have negative 12 over 8. Negative 3 over 2 centimeters per second. Yeah, negative just means it's decreasing. Positive means it's increasing, which makes sense. I mean, if the hypotenuse stays the same length and you're increasing the length of one side, the other side has to decrease to Well, how do I know to put it there? Okay, so one leg, blah, 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 blah. When it is 6 centimeters long, okay, so the 6 centimeter long side is increasing. So it's just the whole English sentence structure. I might have said when it's 6 centimeters long, it's increasing at a rate of 2 centimeters per second or something. And then a ladder 13 meters long is resting against a flat building. The bottom of the ladder is being pulled along the ground at a rate of 3 meters per minute. So here we are. We've got a ladder. Your friend's standing on it. It's 13 meters long. Here we are. You're leaning on the ladder. Somebody runs up and ties the rope to the ladder and starts to pull it away from the wall. Now this is a pretty slow motion kind of accident. 13 meter long ladder is resting against a flat building. The bottom of the ladder is being pulled along the ground at the rate of 3 meters per minute. So we better put a 3 here. 3 meters per minute. How fast is the height of the top of the ladder decreasing after 4 minutes? Okay, so we have to assume the ladder was right up against the wall when we started. And we've been pulling on it for 4 minutes. So this is 12 meters, yeah. So 12, 13, find the missing side of the triangle. Anybody know the Pythagorean triples well enough yet? 7, no. 11, no. 6, definitely not. It is 5. 5, 12, 13. Because it's 3 meters per minute times 4 minutes. This is kind of a slow motion accident. How did I get the 12? 3 meters per minute times 4 minutes is 12 meters. We have to assume that the ladder starts against the wall. It says resting flat against a building. Yeah, I guess I should have drawn the picture. Here we are. Here's Dylan on the ladder. And then time passes and it's like that over there. 4 minutes pass. Dylan's still on the ladder going, this is stupid. Okay. So we know 5, we know 12, we know 13. We know x is 12. We know dx dt is 3. We know y is 5. dy dt we're trying to find out. Z is 13. What's dz dt? 0, because it's not one of those telescoping ladders that extends as it... Yeah. So grab the Pythagoras derivative x dx dt plus y dy dt equals z dz dt. Put all the numbers where they need to go. 5. So 12 times 3, 12 times 3 plus 5 times dy dt equals 0. 36 over 5. 7.2 minutes. 7.2 meters per minute. Negative. He's really moving now. What? No, he's pulling the bottom out, so it's like this. So right at the bottom, it's finally. It's really slow up till now, but now it's starting to speed up. He has like 20 seconds to get off the ladder. Well, we can't have any dangerous stunts here. Come on. So dy dt equals negative 36 over 5 meters per minute. Okay. How many different ways can we do Pythagoras? I don't know, hey? Anybody noticing this yet? How many different ways we can do Pythagoras? Okay. Police cruiser. Approaching a right-angled intersection from the north, is chasing a speeding car that has turned the corner and is now moving straight east. When the cruiser is 0.6 miles north of the intersection and the other car is 0.8 miles to the east, the police determine with the radar that the distance between them and the car is increasing at 20 miles per hour. If the cruiser is moving at 60 miles per hour, what is the speed of the speeding car? Isn't this exciting? This is what radar guns actually do, by the way, folks. Radar gun. Okay. Right angle intersection from the north. So this is kind of what's happening. I'm going to put some arrows here. So when the cruiser is 0.6 miles north and 0.8 miles to the east, that the distance between them and the car is increasing. Okay. So we know dz dt is 20. If the cruiser is moving at 60 miles per hour, okay, look at this. Is the distance increasing or decreasing as the police car approaches the intersection? Decreasing. It's a negative 60. Okay? Most people will say positive 60 and get the wrong answer. The speeding car is going at 4 miles per hour. No. Okay. So you got to watch that. So we'll call this y. So y is 0.6. dy dt is negative 60. X is 0.8. dx dt is what we want to find out. dz dt is 20. We need to figure out what z is. What? 0.1? Close. 1.0. It's a 3, 4, 5 triangle, just in a really fancy form. If you don't like that I can pull those 3, 4, 5, 5, 12, 13s out, just use Pythagoras. 0.6 squared plus 0.8 squared is 1. 1 squared it is 1. Don't be shy to go and do that, right? That's not fair to make the question get the wrong answer because you're what's the word? You're a little bit embarrassed that I'm doing it quickly and you have to do it the other way. That's fine. Okay. Not everything's a Pythagorean triple. We'd like them to be, but not everything is. X dx dt plus y dy dt equals z dz dt. So 0.8 times dx dt plus 0.6 times negative 60 equals 20 times 1. Is it 3.6? 6 times 6 is 36. Kick it back 1. No, it's 360. Kick it back 1, 36. So dx dt is 56 divided by 0.8. I don't know, 70 miles an hour. Which is about 120, 130 kilometers an hour. He's moving. 60 is 110, isn't it? Or 100? 60 is 100? Yeah. Okay, last one.
A hot air balloon is rising straight up from a level field, tracked by a rangefinder 500 feet from the liftoff point.
I think it'd be funner if it was the Space Shuttle Columbia going straight up, because the angle's much faster. But anyways. Hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the liftoff point. At the moment, the rangefinder's angle of elevation is pi over 4. The angle is increasing at a rate of, so what we're saying here is theta is pi over 4, and d theta dt is 0.14 radians per minute. How fast is the balloon rising at that moment? So this is x. Okay, so there's some things we need to fill in. dy dt is what we're trying to find. But we do know what y is, and we do know what y are. We do know what y is, and we know what dx dt is. You might not like how I know what y is, but I know what y is. Grade 9 trig, right? Good. So you can come over here and you can go tan of pi over 4 equals y over 500. Good. So y equals 500 tan pi over 4. Make sure your calculator's in radian mode here. Yeah, most of us would just remember what the pi over 4 triangle is and go, it's 1, 1, root 2, 500, 500, 500, root 2. But If it's not pi over 4, then you have to do what you're suggesting in the box. That's right. So 510 pi over 4 is 500. I'm just going to tell you that. So we know this is 500. We also know dx dt. No, the hypotenuse is 500 root 2. 500, 500, 500 root 2. But dx dt, what is it? 0. He's not moving towards the balloon. Is he? No. Okay, write a relationship that involves the opposite and the adjacent sides of a triangle. Tan theta equals y over x. The derivative secant squared theta equal, or times d theta dt equals derivative of the top, dy dt, times the bottom, x, minus the derivative of the bottom, dx dt, times the derivative of the top, y, all over the bottom squared. Hey, Mr. App, haven't we done this before? So, secant squared theta, secant squared of pi over 4. Secant squared of pi over 4. Cos squared of pi over 4 is 1 over root 2. Secant squared is, cos of pi over 4 is 1 over root 2. Cos squared of pi over 4 is 1 over 2. Secant squared is the reciprocal of that, 2 over 1. Now, if this wasn't pi over 4, if this was some angle like 0.26 radians, I would do the same thing, but I would reach for my calculator. I'd type cos 0.26 in my calculator, get an answer, square it, and then reciprocate it. And I would put that number there. d theta dt is 0.14. What's dy dt? That's what you're asking me to find. What's x? 500. What's dx dt? 0. So who cares about the rest of it? All over x squared. Thank you. Take the 500 over to the other side while you're here. And you get 2 times 0.14 times 500. Yeah. I like trig derivatives. If it ain't subtle, I like Pythagoras derivatives. I like trig derivatives. Can you see that this actually has some application? Like of all the stuff that we've done up to now, related rates, you can actually do stuff with this. It's still contrived because the situations we're giving you are pretty simple. When I give you the not simple ones, then you go, OMG, right? But we're not going to do that to you yet. A man is walking away from a street light at a rate of 5 feet per second. The man is 6 feet tall and the light is 15 feet high. How fast is the man's shadow lengthening? Okay, I've actually done this. This is dorky. You're walking home at night in the street lights, and you walk and you watch how your shadow changes length as you move away from the. So when you're walking home at night under a street light, check this out. It's kind of neat. It's very counterintuitive. Okay, yeah, I know. You don't care. do you? So I want you to draw me a street light. Right? Oh, da, da. Okay, a man is 6 feet tall and the light is 15 feet high. So this is 15 feet. Six feet. $10 feet. Can you see all that info there that I pulled out of the question?
Mr. App, Mr. App, Mr. App. There are two triangles here and they're both similar to each other.
Yeah? Okay, I'm going to draw the two triangles for you. Yeah, it's over in the outbox.
Is that the green?
Mm-hmm. So there are two triangles here. Triangle number 1. And triangle number 2. Yeah? Okay, call this distance something. X or S? S for shadow? And then this triangle, call this side something. Shadow plus length. S plus L. Okay, let's make a formula relating those two triangles. (15/6) equals Could you write it like this now? Could you write it like this now? Take the derivative. 9 ds dt equals 6 dl dt. What's dl dt? 5. What blew me away is it doesn't really matter how far you are from the light. That 10 feet doesn't matter. I thought, oh crap, the farther away it is, of course it's going to... No. It doesn't matter. All that matters is how fast you're walking. Is how fast the shadow length is increasing. I thought when you get farther and farther away that it would be exponential or something. It would depend on that length, the distance you're away. But all it is just how fast you're walking. Kind of cool, I think. Whatever that is. 6 times 5 is 30. 30 over in feet per second. So it's increasing at a linear rate depending on how tall you are. that cool? It's one of those so counterintuitive things. For me, it was totally counterintuitive. Your shadow's going to be longer, but it's going to increase at a constant rate depending only on how fast you're walking, not how far you are from the light. I think that's cool.